Okay, so here we go. We are going to be graphing parabolas today. We have the function f of x is equal to a times the quantity x minus h squared plus k. We're familiar with the a, h, and k from working with absolute value functions on the previous section. And before we begin actually graphing these functions, what we want to do is take a look at what it means to be even and what it means to be odd. What is an even function? What is an odd function? If the function is even, that means that after one reflection across the y-axis, we get back our original function. If the function is odd, then it will take a series of two reflections to get back our original function. That meaning a reflection across the y-axis and then another reflection across the x-axis, and we would have the original function back. Let's go ahead and start by looking at the function x squared. X squared is a parabola. What we're going to do first is we'll reflect it across the y-axis to see if we get our original function back. If we do, then it's symmetric about the y-axis, and that would mean that our function is even. So here you notice that we reflected across the y-axis. It is symmetric about the y-axis, meaning that this function is in fact even. If our function is even, then that means it cannot be odd. It's either one or the other. Now let's go ahead and take a look at a function that we're used to seeing, we've worked with before in the previous section. It is the absolute value of x. Let's go ahead and reflect this across the y-axis to see if we get back our original function. Is this function, the absolute value of x, symmetric about the y-axis? So there it is. We reflected it across the y-axis and it is symmetric about the y-axis. If it is symmetric about the y-axis, then that means that our function is even. If our function is even, then it cannot be odd. So far we've looked at two functions, x squared and the absolute value of x, both of which are symmetric about the y-axis. Both are even and not odd. Here is another function. Here we have this function f of x is equal to x. Let's go ahead and reflect this one across the y-axis to see if it's symmetric about the y. Upon taking a look at this one, when we reflect it across the y-axis, its slope changes from positive to negative, so it is not symmetric across the y-axis. If it's not symmetric across the y-axis, then we know it's not even, and then it might be odd. So that's what we're going to have to look into next. Is this function an odd function? So let's take a look. The next thing that we want to do is, if it is going to be odd, we need to reflect it across the x-axis now to see if we get back our original function. So reflection x-axis, what does that look like? And then we take a look, and in fact, after a series of two reflections, one across the y-axis, another across the x-axis, we do get back our original function. And if it says a function is even about the origin when it looks the same after two reflections in the x-axis and in the y-axis.